Okay, well, let's continue with stacks and queues. For today, as the last part of our lecture, we're going to do stacks. Okay, so let's begin with one of my least favorite stacks because my favorite stack, as you can imagine, is a stack of warm, delicious pancakes on a Saturday morning. Ooh, delicious. Okay, well, but this is one of my least favorite stacks, a stack of dirty dishes. Okay, so let's say that I invite you all for dinner at my place. Okay, and the dinner that I am going to be serving is enchiladas. Because as I always say, let's do the whole enchilada. Okay, so then we're eating and everybody's very happy. And of course, because you're my guests, I will be doing the dishes. However, you're very kind, and whenever you're done eating, you grab your plate and you put it in the stack of dishes. So let's say that June finishes first, then Jerome, then Mitch, then Cy, and so on. Whoever is the last person to finish is gonna be, let's say, somebody from online. Let's say Ashley is the last person to finish because she's a lady and she eats slower than you guys, right? So because she's the last one to finish, she's gonna be the one that is gonna be putting her plate at the very top. Okay, so if I am going to begin doing the dishes, I am not going to start the dishes from whomever finish first. The first plate that I will be washing will be Ashley's plate because that's the one that is at the top of the stack. I am not going to go digging into the stack, but I am going to start cleaning from the top. So that was the best example that I could give you about a stack. Okay, a stack is known as the last in, first out structure. Okay, in this case, the last plate that had gotten into the stack was the last plate of the plate of Ashley, which was the last one to finish, right? Because everybody finished before her. And then that was going to be the first one that I was going to be washing, okay? Now, the last in, first out is also called LIFO, a LIFO structure, or last in, first out structure, or a stack. They are all the same thing. Now, I want you to visualize the PEZ dispensers because that is the best example of real world stack aside from doing the dishes. Okay, I didn't mention the stack as a pancake stack because usually that one I cut all the way from the top to the bottom to eat my pancakes, right? But in this case, the stack for the PEZ dispensers, you put them from the top and then when you pop them out, you push them from the top. And literally, I wanted to put push and pop, and you have the nice Star Wars PEZ dispensers here because when you push the little, the little pills inside, the little PEZ stuff, and then when you get them out, you pop them. You jump one out, so you push an element and you pop an element, and that's the way that it works. You cannot actually go into the PEZ dispenser like Yoda's one, for example, and try to look from one PEZ particular right here in the middle or even the first one that you got. That's not the rule for the stack. The rule says that the last one that you put in is going to be the last one, the first one to come up. So in a linked list, if we have a stack, we begin with the last and first pointing to the same node. Now notice that a stack is nothing but another list. It's yet another linked list. The difference with the stack and any other list is the way in which we access and operate on the elements for the particular stack. So as I said, we have the last and first in here. So when I add another, when I push an element, I move last right here. And remember, the first one in is going to be the last one out, and the last one in will be the first one out. So if I wanted to get that out, I will just move last over here, and this one will be gone. Okay? So in here now, if I have last, I move again, and last is still has the reference to the whole stack, and first is in here. In a stack, really, you don't even need to have a pointer to first because that is something that you will never even access. The one thing that you always need is to have last, a pointer to last. And that's always the case because otherwise you lose reference, right? Now, if I add yet another one, so let's move the list a little bit here, last will still remain there and first is there, but we don't really need it, okay? So the order in which the elements are added to the stack is very important and should not be altered, okay? I am not saying that certain elements go first or last or anything like that, but if an element goes in a certain order, remember that the last one in should always be the first one out, okay? In order to pop an element from the stack, the elements that were added after the elements should be popped first. Like I was saying, you cannot go into the pass dispenser and get something from the middle. If you want to get something from the middle, you will need to start popping the stuff, all the other pills from the top, so that the stack will actually keep its intended functionality. Another thing, when you print a stack, you should also do that last in, first out. Okay, there is no way that you're going to be adding, following the last in, first out style, but at the time of printing the stack, you're going to print it the other way. That is not going to happen. So the stack has those particular rules. It's not just that the last one in is going to be the first one out, but the last one in will also be the first one to be accessed when you are iterating through the structure. That means when you're visiting each one of the elements of the stack. Now, if you access a stack in any other way, it will violate the stack rules, okay? Whatever you do different, if you create an interface for the stack and you decide that you want to be able to access any element in the middle, then I am telling you right now that is not a stack because that is not following the rules, okay? You may be able, because this is America again, you may be able to do whatever you want with a data structure, with a list that you can call it my list or Blanca's special list or something like that, and it's going to do whatever you want, and you can specify that in the interface. But when you're going to be creating a stack as defined by the stack rules, the last element in should always be the first element out. There is no adding anywhere else. There's no inserting elements in the middle. There's no popping elements from anywhere else but from the top. Remember that stack of dirty dishes, okay? That is the best thing to remember. So you cannot insert ever elements but at the very end of the stack. In this case, at the very top of the dirty dishes, right? And you cannot wash any of those dirty dishes but from the end of the stack, or in this case from the top of the dirty dishes, because you add new dishes at the very top and you begin washing from the very top. So keep that in mind because that is a stack. Now, if we want to create a stack interface, just like we have been creating interfaces for other data structures, we need to determine the rules to access the stack. What will those rules be? So you have to keep into consideration that a stack is the last in, first out. That's the very first thing that you need to remember, and then you can go from there, okay? What I want you to do so that we can practice is that I want you to write down the interface for the stack following the same rules that we use for the sorted list. What I mean by these rules is not that the sorted list and the stack are the same. They are not. But the same way in which we were working the methods out and saying, okay, if I want to add, where do I add the element? Does it matter where I add it? Can I add it in one end? Can I add it in the other end? What is easier for me to do? In this case, we have different rules because the stack definitely tells you that you can only add at the end, and at that end, at the top, let's say at the top of the stack, you can only add at the top of the stacks. And when you're going to be removing, you're going to actually be removing also from the top of the stack. So you have certain things that have already been delimited. So now you need to make sure that you can, instead of writing add or remove, you have to add push, you have to write push and pop. And you still have an iterator that it's going to print throughout the interface, or access the not the interface, that is going to access the stack. And remember, the access of the stack needs to be also done, and the last in, first access. So you can go that way, only that way. If you have any questions about this, please send me an email. Otherwise, I do the other part that I ask you to do about the sorted list in JGrasp. If you have any questions, you send me an email, and I sincerely and totally hope to see you all on Wednesday. You take care of yourself.